Tonight, we're going to explore one of the quietest and most unsettling questions in modern science. Not a question about distant stars or alien worlds, but a question about the ground beneath your feet and what it might no longer remember. Earth is 4.5 billion years old. Complex life has existed for 400 million years. Dinosaurs reigned for 150 million. Human industry has lasted barely 300. And in all that vastness of time, the planet itself has been quietly erasing its own past. No oceanic crust on Earth is older than 200 million years. Less than 3% of the surface holds our cities. Less than 1% of all species that ever lived left fossils behind. The continents drift a few centimeters each year, swallowing whatever rests upon them. By the end of tonight, you're going to understand why the absence of ruins proves nothing, why the chemical signatures buried in ancient rock remain ambiguous between nature and intention, and what the Paleocene-Eocene thermal maximum and the Silurian hypothesis reveal about the limits of what stone can remember. Before we get started, if you love exploring the depths of space as much as we do, take a second to like the video or subscribe. It's a simple action, but it helps this channel reach more curious minds like yours. Now, let's begin. Think about what 300 years actually means. Not in human terms, not in the span of a lifetime or a dynasty or an empire. In geological terms, 300 years is less than a single heartbeat in the life of this planet. It is a rounding error. It is noise. Earth has been here for 4.5 billion years. Complex life, the kind with bones and organs and nervous systems, has been crawling and swimming and breathing across this surface for 400 million years. The dinosaurs alone ruled for 150 million. They were here, dominant, world-filling, and then gone. And the planet had 66 million more years of business before anything resembling us appeared. And human industry, the factories and roads and power lines and plastics that we think of as our permanent mark on the world, has existed for 300 years. Maybe less, depending on where you draw the line. So here is the question that changes everything. What if we are not the first? The standard objection arrives immediately. We have found no ruins, no ancient factories buried under the Sahara, no highways pressed into the bedrock of the Pacific, no city lights in the fossil record. If another civilization had risen and built and burned, we would have found something by now. That objection feels solid. It feels like common sense. But here's where it gets strange. The objection assumes the planet keeps things. It does not. Earth is not a museum. It is a recycling system. And it has been running that recycling system for a very long time. Think about tectonic plates. They move only a few centimeters every year. That sounds trivially slow. In a human lifetime, the ground beneath you shifts perhaps 2 or 3 meters. You would never feel it. You would never notice. But over millions of years, those few centimeters per year add up to continents crossing oceans, mountain ranges rising and dissolving, ocean floors sliding beneath continents, sinking into the mantle and melting back into raw rock. The entire surface of the planet is in motion, and that motion destroys everything resting on top of it. Here's the number that stops most people cold. No oceanic crust on Earth is older than 200 million years. Not a single piece. The ocean floors, all of them, have been created and destroyed and recycled completely within the last 200 million years. The same process that builds new seafloor at volcanic ridges swallows old seafloor at subduction zones, pulling it down into temperatures and pressures that reduce any structure, any chemistry, any artifact to undifferentiated melt. Whatever sat on that ocean floor goes with it. Not preserved. Destroyed. Completely. Now, think about land. Continents are more buoyant and resist subduction better than ocean crust, but they are still ground, eroded, folded, buried, and metamorphosed over long enough timescales. A city built 50 million years ago, on a coastline that no longer exists, on rock that has since been compressed and reheated, would leave nothing recognizable. The metals would dissolve. The ceramics would be indistinguishable from natural mineral deposits. The foundations would be folded into mountain roots. And if the city sat near a subduction zone, the entire region might simply be gone. Here is another number worth sitting with. Less than 3% of Earth's surface currently holds human cities. 3%. That means even if you were searching for our civilization from the distant future, armed with every geological tool available, you would be looking for traces concentrated on a tiny fraction of the surface. And that surface is actively being reworked on timescales of tens of millions of years. Less than 1% of all species that ever lived left fossils behind. 1%. Fossilization requires a very specific sequence of events, a very specific chemistry, a very specific burial environment. The overwhelming majority of everything that ever lived simply decomposed and vanished. The fossil record is not a catalogue. It is a handful of extraordinary accidents. What this means, taken together, is something worth saying plainly. The absence of ruins is not evidence that no one was here. It is exactly what we would expect to find, even if someone had been here. The argument cuts in both directions. And there is a sharper edge to this. The same mechanism that might preserve evidence is also what destroys it. Deep burial protects material from surface erosion, but deep burial also means heat and pressure and chemical transformation over millions of years. The rock layer that holds the chemical record of 50 million years ago is the same rock layer being altered by the processes that carry it toward the mantle. We are not looking for evidence in a stable archive. We are looking for evidence in a system designed to erase itself. Here is what this means for the search. The question is not whether ruins survive. They cannot. That is the wrong question. The right question is whether something subtler survives. A chemical fingerprint. An isotope ratio that sits slightly outside the range geology alone would produce. A spike in some element in a layer of ancient rock. A spike with no obvious volcanic or cosmic explanation. These things can survive even when physical structures cannot, because they are woven into the chemistry of the rock itself, rather than sitting on top of it. This is the reframe that carries everything else forward. Not ruins. Chemistry. And the unsettling part, the part that the geology alone cannot answer, is whether we have already been looking at chemical signatures like this without recognizing what they are. Ancient rock holds records of temperature swings, atmospheric shifts, carbon pulses, and strange isotopic anomalies. Some of those we attribute confidently to natural causes. Some we attribute confidently to specific volcanic events. But some sit in categories that remain genuinely ambiguous, where the signal is real, but the explanation is still being worked out. Whether any of those ambiguous signals could represent something other than a natural event is the question this investigation has only begun to ask. The chemistry is specific, the rock is real, and the biggest surprises are still ahead. Before we cross into the chemistry, stand still for a moment. Feel the weight of what we are actually talking about. Because the numbers have been named, but named is not the same as felt. And until you feel them, they are just numbers. Imagine you are standing on a beach at night. The water is somewhere in the dark ahead of you. You reach down and pick up a handful of sand. In your palm, you are holding somewhere around 10,000 individual grains. 10,000. That number, roughly, maps to the full span of human civilization. Every pyramid ever built. Every empire that rose and fell. Every war, every treaty, every cathedral, every road. Agriculture. Writing. Mathematics. The wheel. All of it, from the first settled villages to this moment, fits inside a single handful of sand. Now, look up from your hand and look down the beach. The shoreline stretches away from you into darkness, curving toward a horizon you cannot see. That beach, the full length of it disappearing into the night, is 4.5 billion years of Earth's history. And the handful of grains you are holding, that is where humans have been. The rest of the beach is not ours. That is not a poetic exaggeration. That is the ratio. One handful against an entire dark coastline. But the beach frame, as striking as it is, still allows the mind to slip into vagueness. The brain hears 4.5 billion years and files it under very long time. It does not sit still long enough to feel what that means. So there is another way to approach this. A way that forces the mind to slow down and actually walk the distance. Compress all of Earth's history into a single calendar year. January 1st, Earth forms. The planet is new. It is hot and largely molten, still absorbing the last debris from the disk of gas and rock that built the solar system. There is no ocean yet. There is no sky as we would recognize it. Fast forward to late February. That is when the first life appears. Simple cells, bacteria most likely. No nucleus, no complexity, just the bare chemical machinery needed to copy itself and survive. Life has arrived, but it would be unrecognizable as life to a casual observer. And then, almost nothing changes for months. Spring passes, summer passes, autumn passes. The entire spring, summer, and autumn of this compressed year belong entirely to microbes. Nothing with a backbone, nothing with a nervous system, nothing visible to the naked eye. Just a billion years, then another billion years, of microscopic life quietly running chemical reactions in ancient seas. The world is alive, but to any observer standing on the surface, it would look empty. It would look like rock and water and sky. Late November is when complex life finally crawls onto land. Not humans, not mammals, not even reptiles yet. We're talking about early plants, early insects, early amphibians. The basic architecture of complex living things finally making the move from ocean to shore. December 13th. That is when the dinosaurs appear on the calendar. They arrive in mid-December, and they will dominate the planet for the next 13 days of this compressed year. 13 days. That is roughly 150 million years of actual time. Every species of dinosaur that ever walked, swam, or flew, every ecosystem they built, every predator and every prey animal, every forest they moved through, every beach they crossed, all of it fits between December 13th and December 26th. December 26th, the asteroid arrives and the dinosaurs are gone. The remaining 5 days of December, from the 26th through the 31st, belong to the mammals who inherit the emptied world. Rodents first, then larger animals, then primates, eventually humans. But here is where the calendar becomes almost cruel in its precision. All of recorded human history, every pharaoh, every Caesar, every king and queen, every cathedral and skyscraper and ocean voyage, every written record we have ever found, fits into the final minutes before midnight on December 31st. We are not talking about hours, not even an hour. Minutes. The entire human civilizational record is crowded into the last few minutes of the last day of the year. And industrial civilization, the thing that concerns us most in this investigation, the factories and engines, the cars, the satellites, the nuclear reactors, the particular chemical fingerprints we are asking whether a prior civilization might have left. That fits into less than 1 second before midnight. Not a few seconds, not a minute. Less than 1 second. The brain resists this. It wants to push back. It wants to say that surely we are more significant than that. But significance is not the question. Duration is the question. And on the question of duration, the calendar does not negotiate. There's a third way to feel this, and it is the most stubborn of the three. Start counting. Out loud, 1 number per second. 1, 2, 3, 4. Keep going at that pace, never pausing, never sleeping, 1 number per second. To count from 1 to 3 million, which is roughly how old the oldest known stone tools are, the earliest physical evidence we have of our ancestors doing something recognizably intentional, you would need about 35 days. 35 days of continuous counting, 1 number per second, to reach the beginning of our tool-using history. Now keep counting. You are not done. Keep going. You need to count all the way to 150 million, which is how long the dinosaurs were here. At one number per second, that takes you roughly 5 years. 5 years of counting without rest to traverse the span of dinosaur dominance, a span that on the December calendar occupies 13 days. Sit with that. Physical evidence of our species and its immediate ancestors covers perhaps 3 million years at the very outside. 5 years of counting gets you to 150 million. The dinosaurs were here 50 times longer than the entire span from the first stone tool to today. The physical record of humans on this planet is a sliver of a sliver. Not a minor chapter, not a brief chapter. A fraction of a chapter whose length, if rendered in seconds of counting time, does not survive comparison to what came before it. This is not a detour from the question of a prior technological civilization. It is the foundation of the question. Because what the beach and the calendar and the counting are all saying, from 3 different directions, is the same thing. The window in which our kind of civilization could have existed and vanished without leaving physical traces we would recognize is not a narrow edge case. It is enormous. It is most of the beach. And the chemistry we mentioned, those ambiguous signals in ancient rock, those isotope ratios that sit slightly outside the expected range, that is where we are headed next. Think about the creatures that lived through all those Decembers, through those Novembers, through the long microbial summers stretching across hundreds of millions of years. They were real. They had bodies, behaviors, whole ecosystems built around them. And then they were gone. Not just extinct. Gone from the record, vanished so completely that we have no idea most of them ever existed. This is the part that the museums accidentally hide from us. Walk through any natural history museum and you will see cases full of dinosaur bones. Shallow seas preserved in limestone, insects caught forever in amber. It looks abundant. It looks like the Earth kept good notes, but that impression is exactly wrong. For every skeleton mounted behind glass, millions of individual animals left nothing. Not a bone, not a tooth, not a single footprint in stone. The museum is not a representative sample of life on Earth. It is the extreme exception. It is the lottery winner displayed in a frame on the wall, with no mention of how many tickets were never even printed. And here is the reason. Fossilization is not a process that happens to the dead. It is a chain of conditions, every link of which must hold. Break one link anywhere and the organism simply dissolves back into the planet without a trace. Think about what has to go right. First, the animal has to die in exactly the right place. Not in a forest, not on an open plain. Forests rot their dead. Open plains scatter and bleach them. To have any chance, a creature needs to fall into a river delta or sink into the still water of a shallow seafloor with fine sediment waiting to receive it, or stumble into a tar pit, or settle onto a lake bed with no oxygen to feed decay. Most animals in the history of life died in none of those places. They died where they lived, and the landscape consumed them. Second, burial has to happen fast. Not eventually. Fast. Scavengers can strip a carcass in days. Bacteria break down soft tissue in weeks. Weather and water and simple exposure take care of whatever is left. The window between death and burial, if it is too long, erases everything. Most creatures never make it past this step. Third, even proper burial is not enough. The sediment surrounding the remains has to compact, over thousands of years, into stone. The organic material in the bones has to be replaced, slowly, molecule by molecule, by minerals seeping through groundwater, not absorbed, replaced, precisely. One mineral atom for one organic molecule, over and over, until the bone is no longer bone at all, but a perfect stone replica of bone. This process takes time measured in millions of years and requires exactly the right mineral chemistry in exactly the right water. But here's where it gets strange. Even after all of that works, the stone itself has to survive. The rock containing that fossil then has to endure tens to hundreds of millions of years without being caught by a subduction zone and dragged back into the mantle, without being caught in a collision between continents and metamorphosed into something unrecognizable, without being exposed at the surface and eroded grain by grain into the sea. Most rock does not survive that long. The planet grinds and swallows and remakes itself continuously. Stone that holds a fossil is just another piece of stone to a tectonic plate. It does not get special treatment. And then, after all of that, someone has to dig in the right spot, at the right depth, in the right century, before erosion exposes and destroys the fossil faster than anyone can find it. Not one condition, not two, every single condition, in sequence, without a single failure. The result is what you would expect from a process that demanding. Roughly 1 in every 100 species that ever lived left anything behind. Possibly fewer. The number is hard to calculate precisely because we are, by definition, counting only what survived. We have no way to count what vanished entirely. That is the nature of total absence. Think about a single forest. Thousands of species living in the same few square kilometers. Trees, fungi, insects, amphibians, birds, mammals. Things we do not have names for. All of them alive at the same moment. All of them eventually dead. How many would fossilize? Perhaps a handful. Perhaps none. Perhaps the entire ecosystem, every organism from the largest predator to the smallest soil bacterite, leaves the planet exactly as it found it. No trace, no record. As if it never assembled itself into the complex, interdependent thing it was. That is the geological record, not a library. A burned library. 99% of the books are ash. The remaining 1% are water damaged, with pages torn out and the text translated through 3 different languages before it reached us. What we know about life on Earth is reconstructed from fragments of fragments, and those fragments only survived because a very specific series of unlikely events broke in their favor. Now consider where we have built our civilization. Human cities are not distributed evenly across the planet. They cluster near coasts and rivers. They cluster in low-lying areas where soil is fertile and water is accessible, and trade was historically possible. These are exactly the places most vulnerable to geological change. Coastlines flood and recede, river deltas shift and bury and re-expose their layers. Low-lying regions collect sediment, yes, but they also sit in zones where tectonic activity is most likely to rework the crust over the timeframes we are discussing. And our materials are not durable in any geological sense. Steel corrodes, concrete fractures and absorbs groundwater and eventually disaggregates back into its component minerals. Glass is chemically stable for thousands of years, but brittle and scattered easily by any significant geological disruption. The roads and airports and data cables and steel frameworks of our cities are not made of the materials that fossilize well. They are made of the materials that recycle quickly. If nature struggles to preserve creatures that lived everywhere on this planet for hundreds of millions of years, what odds does it give to a civilization concentrated in its most geologically vulnerable zones, built from materials that corrode and fracture and dissolve, existing for a period that on the compressed calendar we laid out does not survive as a measurable interval at all? The answer is not reassuring. The geological record only remembers exceptions, the lucky ones, the creatures that happen to die in the right place at the right time, in the right chemical environment, and whose remains happen to sit undisturbed in the right kind of rock, for the right number of millions of years before a human being happened to excavate the right hillside. That is who gets remembered. The ordinary creatures vanished without leaving a line of text anywhere in the planet's stone archive. And we have no particular reason to believe we are not ordinary. The chemistry, though, is a different story, and that is where the odds change. The chemistry is one part of the answer. But before we get to what survives, we need to understand what destroys. And the planet does not leave that work to chance. Earth runs 3 separate erasure systems. Simultaneously, without pause, and they have been running for billions of years. Together they cover every domain where evidence might hide. Nothing sits outside their reach. The first is the most visible: rain, rivers, wind. Every raindrop that falls on exposed rock carries something away with it. A microscopic particle, a grain, a dissolved mineral. Individually, each one is invisible. Collectively, over millions of years, they move mountains. Literally. The Colorado River has been cutting through rock for roughly 6 million years. That is the timescale required to produce a canyon 1 mile deep. 6 million years of water moving downhill, carrying particles, grinding stone against stone. The Grand Canyon is not an exception to how Earth works. It is an illustration of it. A granite peak, one of the harder materials on the surface, loses about 1 millimeter of height every 1,000 years. That sounds like nothing. Over 10 million years, that is 10 kilometers of rock gone. The mountain ceases to exist. Whatever was built on it, buried in it, or preserved near it, goes with it. Erosion does not care what it is carrying away. It does not distinguish between ordinary stone and the concrete foundation of something that once mattered. It just moves material downhill, into rivers, toward the sea. And that is where the second system begins. Tectonic plates move at roughly the speed of a fingernail growing, a few centimeters per year. Imperceptible, but over millions of years, those centimeters accumulate into thousands of kilometers. The plates do not simply drift, they collide. And where oceanic crust meets continental crust, the oceanic plate loses. It slides beneath the continental plate and descends into the mantle, down into temperatures and pressures that no material survives intact. The rock melts. Anything embedded in it, any chemical structure, any mineral record, any trace of anything that was once on that seafloor is destroyed at the molecular level. It becomes new magma. It carries no memory of what it was. Here is what that means in practice. No oceanic crust on Earth is older than 200 million years. None. Not a single piece. The seafloor that existed when the first dinosaurs appeared has been entirely consumed and remade. The Pacific Ocean, which covers more of this planet's surface than all the continents combined, has been recycled multiple times since complex life first appeared. We tend to picture the deep ocean floor as ancient and undisturbed, still, remote, preserved by its own darkness and depth. It is not. It is one of the most aggressively destroyed surfaces on the planet. The conveyor belt runs constantly, feeding old material into the mantle and building new seafloor at the ridges. The ocean floor is not a record. It is a furnace. But here's where it gets strange. Even the material that never reaches the seafloor is not safe. The third system works from below, on the rock that gets buried rather than subducted. And in some ways, it is the most insidious of the three. Sedimentary rock is where fossils form. When an organism dies and is covered by sediment and the sediment slowly compresses into stone, the result is sedimentary rock, the only kind of rock where biological detail can be preserved. Paleontologists depend on it entirely, but sedimentary rock does not stay sedimentary. Push it deep enough, subject it to enough pressure and heat, and it transforms. Sandstone becomes quartzite, shale becomes slate, limestone becomes marble. These are not small chemical changes. The transformation is total. The crystal structures reorganize from the ground up. Whatever delicate features were once there, whatever microscopic traces, whatever chemical signatures embedded in the original sediment, are obliterated. The atoms rearrange into something new and carry nothing forward from what came before. The word for this process is metamorphism. Think of a page of text that has been scraped clean and written over, now scraped again and written over again, and again. By the time you encounter the surface, it contains writing, but it is not the original text. Nothing of the first draft survives. That is what metamorphism does to the rock record. And now consider all three together. Erosion attacks what is exposed at the surface, it wears it down, and carries it toward the sea. Subduction devours what arrives at the seafloor. It pulls it into the mantle and melts it into new rock with no memory. Metamorphism transforms what gets buried instead of eroded, eliminating the fine detail that preservation requires. Each system covers a domain the others do not fully reach. Exposed surfaces go to erosion. Ocean floors go to subduction. Buried sediment goes to metamorphism. There is no domain that sits outside all three. There is no geologically safe location where evidence simply accumulates undisturbed across tens of millions of years. These systems have been running for billions of years. They ran before the dinosaurs. They ran while the dinosaurs existed and after the dinosaurs were gone. They are running right now, at this moment, dissolving and consuming and transforming the material record of everything that ever existed on this surface. Against that, 300 years of industrial civilization is a single breath in a windstorm. Not a brief era. Not a recoverable interval. A breath. The processes do not slow down for material that is culturally significant. They do not distinguish between an ancient seabed and the ruins of something we would recognize. They move through everything at the same indifferent pace. The mechanisms are not the final answer. They are the context for the question. Because somewhere between total erasure and physical ruins, there is a layer the planet cannot quite reach. And that is where the investigation actually begins. That layer is chemistry, not architecture, not artifacts, not the weight of stone on stone. Chemistry soaks through. It embeds itself in the record the planet keeps, whether or not anything built by hand survives. Think of a manuscript written on parchment. The writing can be scraped away. The surface text disappears. But some inks do not stay on the surface. They soak through. They stain the material beneath the words, and that stain does not scrape off. Industrial civilization has been writing in that kind of ink, not with parchment and quill, with carbon and plastic and heavy metals and something far stranger. And the stain it leaves does not require a single building to still be standing. Start with carbon. Since the beginning of the Industrial Revolution, humans have released roughly 550 billion tons of carbon into the atmosphere. That number is worth sitting with for a moment. 550 billion tons. If you gathered all of that carbon and piled it into a single mass, you would have a mountain larger than anything currently standing on Earth. That is what we have added to the air in 300 years. But the mass is not the signature. The signature is the ratio. Carbon comes in different forms, called isotopes. The two relevant ones are carbon-12 and carbon-13. Natural carbon in the atmosphere carries a particular balance between them, a ratio that has been relatively stable for hundreds of millions of years. Fossil fuels are ancient organic matter, and ancient organic matter has a slightly different ratio, weighted more heavily toward carbon-12. When we burn fossil fuels, we are pumping that carbon-12 heavy carbon into the atmosphere, and that shifts the global ratio in a measurable direction, a very specific direction, one that does not occur naturally from volcanic eruptions or asteroid impacts or any other geological process. And here is the part that turns this from interesting to remarkable. That shift gets recorded. Marine creatures build their shells from carbon dissolved in seawater. Coral reefs incorporate carbon as they grow. Cave formations layer it into stone over thousands of years. Animal bones carry it. The carbon isotope fingerprint of the atmosphere at the time a creature lived is written into its hard parts, which means a geologist 50 million years from now, sifting through the rock record, would find a thin layer where the carbon isotope ratio suddenly lurches in one direction. Not a gradual drift, not a slow volcanic transition over millions of years. A sudden lurch, compressed into a layer so thin it would be nearly invisible to the naked eye. The entire industrial era, recorded as a chemical spike in the stone. That would already be enough to raise questions. But carbon is only the beginning. Consider plastic. We produce roughly 400 million tons of it per year. Polyethylene, polypropylene, polystyrene. These are molecules that did not exist anywhere on Earth before the 20th century. They are not produced by any biological process. They do not occur in any natural mineral formation. They are wholly artificial, and they are extraordinarily persistent. Plastic fragments into smaller and smaller pieces, but the molecular structure resists complete breakdown. It accumulates in sediment. It gets buried. It gets compressed. Over millions of years, it would become what researchers call technofossils. Thin layers of artificial polymer material embedded in the rock, unmistakably distinct from any surrounding stone. A geologist finding such a layer would encounter molecules that had no place in the natural chemistry of this planet. Not a trace element that occurred at unexpected concentrations. Not a mineral in an unusual formation. Molecules that simply should not exist in any natural rock at all. Then there are the heavy metals, lead, mercury, cadmium. We extract and distribute them at concentrations that dwarf anything natural processes produce. Volcanic eruptions release heavy metals, but slowly, in dispersed quantities, over millions of years. The industrial distribution of these elements is different, too sudden, too concentrated, too uniform across the entire planet simultaneously. A geologist reading the record would see the same sharp boundary, normal background levels, and then, in the same thin layer that holds the carbon spike and the polymer fragments, a global heavy metal anomaly that no natural event can account for. We add approximately 65 million tons of aluminum to circulation each year. Aluminum is the most common metal in Earth's crust, so its presence alone is unremarkable. But refined aluminum, processed and distributed globally in concentrated form, leaves a signature in that same layer. Another data point in what is becoming, when you look at all of it together, an unmistakably artificial boundary. But here is where it gets strange. In the 1950s, we added something to the record that no geological process has ever produced. Something no volcanic eruption, no meteor impact, no natural chemical reaction on Earth generates. Starting in 1952 and accelerating through the early 1960s, atmospheric nuclear weapons testing released several isotopes into the global environment. Cesium-137, strontium-90, elevated levels of carbon-14, and plutonium-239. Plutonium-239 has a half-life of 24,000 years. To a geologist working in deep time, that sounds brief. 24,000 years is barely a rounding error against 50 million. Most of the radioactivity fades. Most of the signal blurs. But wait, the half-life is almost beside the point. Before 1945, plutonium-239 essentially did not exist on Earth. Not in trace amounts, not buried somewhere geologists hadn't looked yet. It is produced by stars and supernovae when neutrons are captured by uranium atoms under conditions that do not occur in Earth's crust. The Earth formed with whatever plutonium its parent star contributed, and that plutonium decayed away billions of years ago. By the time complex life appeared, by the time the dinosaurs walked, by the time anything we would recognize as biology existed on the surface, there was no measurable plutonium-239 on this planet. None. And then, beginning in 1945, there was. Not faintly. Not as a statistical whisper. As a detectable global layer deposited simultaneously across the entire planet, appearing in ice cores drilled in Antarctica, in deep ocean sediment, in soil samples from every continent. A geologist, 50 million years from now, even accounting for the decay, would find the daughter products of that plutonium, the chemical residue of its decay chain, and they would face a material that has no natural explanation on this planet. An element that the Earth does not make, appearing suddenly, globally, in a layer that matches the carbon spike and the plastic layer and the heavy metal anomaly, all of it in the same boundary, all of it arriving at the same geological instant. This is the crucial reframe. Physical evidence needs a building to survive, a road to be preserved. a tool to escape subduction and erosion and metamorphism. Chemical evidence does not work that way. Chemical signatures do not depend on a single artifact remaining intact. They spread globally. They embed themselves in sediment forming everywhere at once, on every continent, at the bottom of every ocean basin, in every cave where water deposits its minerals layer by layer. The planet itself becomes the record, not a specific site that must survive by luck, but the entire rock record simultaneously, carrying the same thin boundary wherever rock was forming at that moment. A future geologist would need no ruins, no foundation walls, no corroded metal. They would need only a rock sample containing sediment laid down at the right time, and the boundary would be there. The carbon isotope lurch, the synthetic polymer layer, the heavy metal anomaly, the sudden appearance of an element that stars make and Earth does not. That is what we are leaving behind. Not monuments, a chemical horizon written into the stone of this planet in ink that does not scrape off, which raises a question that has no comfortable answer. If any civilization existed before us and left a similar horizon, would we recognize it for what it was? There is an answer to that question, not a theoretical one, not a thought experiment, an actual answer, written into the rock, waiting to be read. 56 million years ago, the Earth ran a fever. The Arctic Ocean reached 23 degrees Celsius, warm enough to swim in. Where polar bears now hunt across frozen water, crocodiles drifted. Where tundra now stretches to the horizon, palm trees grew. Cypress and fern forests spread across what is now permafrost. Subtropical swamps covered regions we call northern Canada, Siberia, Greenland. The poles were not cold. They were warm and green and full of life that had no business being there, by any measure of the world we know. This event has a name. The Paleocene-Eocene Thermal Maximum. Scientists call it the PTM. It lasted somewhere between 10,000 and 20,000 years. Global temperatures rose 5 to 8 degrees Celsius above the baseline of the world that came before. Ocean currents altered. Weather patterns rewrote themselves across every continent. Ecosystems that had taken millions of years to assemble collapsed. Others formed in their place, strange hybrids of species pushed poleward by heat they could no longer escape. The oceans absorbed heat and carbon dioxide together, and as they did, they became more acidic. Marine species whose shells and skeletons depended on calcium carbonate found those structures dissolving. Slowly, then faster. Mammals migrated toward the poles in search of temperatures they could survive. Species that could not adapt vanished. Not thinned, vanished. This was a mass extinction event. Less famous than the one that ended the dinosaurs, which by this point in Earth's history had already happened roughly 10 million years earlier. But a mass extinction nonetheless. Real species, real populations, real lineages that had existed for millions of years and then simply ceased to exist. The PETM left a mark on life on this planet that took millions of years to fully recover from. But here's where it gets strange. The PETM left something else behind. Something more precise than bones or migration patterns. Something written into the chemistry of the rock itself. A sharp shift in the ratio of carbon-13 to carbon-12. The same ratio the previous section spent considerable time on. The ratio that records the source of the carbon in the atmosphere. And what the rock records, globally, at the exact moment the PETM begins, is a sudden, massive injection of light carbon. The kind that comes from burned organic matter. The kind that comes from old biological material being oxidized and released into the air. Between 2,000 and 5,000 billion tons of carbon entered the atmosphere during this event. Even the lower estimate, 2,000 billion tons, dwarfs anything in pre-human geological history. The carbon spike in the rock at the PETM boundary is not subtle. It is one of the clearest and most dramatic isotope shifts in the entire geological record. Every geologist who has ever studied this period agrees on the signature. The only debate is about the exact source, and that debate is worth pausing on. There is no evidence the PETM was caused by anything other than natural processes. None. The leading hypotheses involve volcanism in the North Atlantic, releasing large quantities of carbon dioxide over thousands of years, and the destabilization of methane hydrates on the seafloor. Methane hydrates are frozen deposits of methane locked into ice-like structures in cold, deep sediment. As ocean temperatures rose slightly, those structures became unstable. Methane, which is itself a powerful greenhouse gas, escaped into the water and then the atmosphere. The warming triggered more destabilization, more methane, more warming. A feedback loop that amplified itself until the signal recorded in the rock was one of the most dramatic climate events in the last 100 million years. The volcanism lit the match. The methane hydrates became the accelerant, natural, entirely natural. Now consider what a geologist would see if shown the PETM signature with no context at all. No knowledge of the date, no knowledge of the cause, just the rock. They would see a sudden global carbon isotope shift, indicating massive release of light carbon. They would see rapid global warming of 5 to 8 degrees. They would see ocean acidification. They would see mass extinction. They would see poleward migration of species. They would see ecosystem collapse and reformation. They would see, in short, exactly the signature that industrial civilization is laying down right now. Burning fossil fuels would be a reasonable hypothesis, not an unreasonable fringe interpretation, a reasonable, scientifically defensible hypothesis. The data would support it. They would be wrong, but the data alone would not tell them that. Not a borderline case, not a marginal resemblance. The PETM signature and the signature of an industrial civilization are, at the level of the chemical record, essentially the same pattern. Carbon spike from organic sources, warming, acidification, extinction, migration, collapse. The rock does not record intent. It does not record cause, it records outcome. And the outcomes of these two very different events, one natural, one the product of technological beings burning ancient sunlight stored in carbon, produce signatures that are, to the rock, indistinguishable. This is not a minor inconvenience in the philosophy of science. It is a fundamental problem. If we are hoping to look at the geological record of deep time and distinguish natural disruptions from artificial ones, the PETM is the test case. And the PETM fails the test cleanly. Not partially, cleanly. A natural event from 56 million years ago passed through exactly the filter we would use to detect an industrial civilization, and it would pass. Every single criterion met. Every box checked. The question we asked at the end of the previous section was whether we would recognize a prior civilization's chemical horizon if we found one. The PETM suggests the answer may be no, not because the evidence would be absent, because natural processes can produce the same evidence. And that changes the shape of the problem considerably. But it raises a question one level deeper. Not about the evidence itself, about the tool we use to evaluate it. Step back from the PETM for a moment. Step back from carbon isotopes and methane hydrates and ancient ocean temperatures. Look instead at the method. Look at the instrument we reach for every time we open a rock layer and find something unexpected. Because the instrument has a shape, and the shape matters. Science works. That is not a small claim, and it is not a ceremonial one. It is the most important fact in this discussion. The scientific method has produced vaccines that ended diseases that killed children by the millions. It has produced spacecraft that cross the solar system and are still sending signals back from beyond the edge of it. It has produced antibiotics, computers, knowledge of how stars age, knowledge of what atoms are made of. It works because it demands natural explanations and then tests them. Rigorously, repeatedly, against reality. It does not accept claims that cannot be checked. It does not defer to authority. It follows evidence. When a geologist opens a rock layer from 70 million years ago and finds an anomaly, a carbon spike, an isotope shift, an unusual mineral assemblage, she asks, which volcano released this? Which asteroid impact triggered this cascade? Which ocean current shifted? Which methane deposit destabilized? Which orbital cycle tightened the climate? These are the right questions. They are right because they have worked before. Every anomaly so far has yielded to exactly this kind of questioning. The tool has earned its reputation. This is not a flaw. It is the strength of science. We refine tools that succeed. We point our instruments where we have found answers before. That is how a method stays reliable across centuries and across generations of scientists who have never met each other and agree anyway, because the evidence forces agreement. But here is where the shape of the tool becomes important. Think about a flashlight in a dark room. The beam illuminates whatever it falls on with extraordinary clarity. The texture of the wall, the grain of the wood. Every detail in the cone of light is visible, precisely visible, better than you could see it in ordinary daylight. But the room is larger than the beam. Beyond the cone, darkness persists. Not because nothing is there, because the light does not reach it. You can sweep the beam methodically. You can cover every inch of the lit area with great care. You can produce a thorough, accurate, completely reliable account of everything the beam has touched. And when you are done, that account will be accurate. Nothing in it will be wrong. But the account will not tell you what is in the rest of the room. The thoroughness of the illuminated survey says nothing about the dark. There is an older version of this problem. A man is searching for his keys at night. He lost them somewhere on the street, but he is searching under the streetlight. A neighbor stops and asks, "Are you sure you dropped them here?" The man replies, "No, I dropped them over there in the shadow, but the light is better here." The search under the streetlight can be meticulous. It can be exhaustive. It can be, in its own terms, complete. And when it finds nothing, it can say with confidence, "The keys are not here." That is true, but it says nothing about the shadow. We have been pointing our flashlight at natural processes for a very long time. Generations. Centuries. When scientists find a carbon spike in the geological record, they ask which natural mechanism produced it. Not because they are incurious, not because they are closed-minded, because the natural mechanisms have answered every question so far, and the flashlight goes where the answers have been. We do not ask whether someone burned fossil fuels. That question feels absurd, and the feeling of absurdity is itself part of how the methodology functions. Most absurd hypotheses are absurd. The filter is usually right. Extraordinary claims require extraordinary evidence, and the burden of proof rests on the one making the unusual claim, not on the one defending the established framework. This is not an arbitrary rule, it is how science avoids chasing noise. But the filter produces a pattern. When a natural explanation fits the data, we accept it. We do not then test the artificial alternative. There is no procedure for that test. There is no protocol for running two parallel inquiries, one natural and one artificial, against the same geological anomaly. The natural inquiry runs. The artificial inquiry does not run. If the natural inquiry succeeds, we have our answer. The case closes. The blind spot remains undisturbed. This is not negligence. It is not failure. It is a structural feature of a method that has been shaped by its successes. The successes are real. The structure is real, and the consequence is real. Here's what the consequence looks like in practice. Suppose a genuine anomaly sits in the geological record. Suppose it has a natural explanation that fits the data well enough to close the case. And suppose, hypothetically, that the anomaly was not natural. The natural hypothesis gets tested. It fits. The case closes. The artificial hypothesis is never tested. Not because anyone decided against it. Because the question was never asked. Because the question feels absurd. Because the flashlight does not point that way. The data alone would not tell us. We already know that. The PETM already showed us that. And now there is a second layer to something established earlier in this discussion. Earth is not a museum. Earth is an eraser. That was the first meaning. Physical evidence gets ground down, subducted, metamorphosed, dissolved. Stone does not protect what it contains from the processes that shaped it. The eraser is physical, it is geological, it operates over millions of years and leaves almost nothing. But there is a second eraser. It operates before the rock is even opened. It operates in the mind of the scientist reading the data. It is the prior erasure of which questions get asked at all. The physical eraser destroys evidence. The methodological eraser destroys the possibility of the right interpretation, even if evidence survives. Think about that sequence carefully. Physical evidence must survive erosion, subduction, metamorphism, and the enormous probability of simply never being excavated. Those are long odds, but suppose something survives. Suppose a chemical horizon makes it through. Suppose a future geologist, or a present one, opens the rock and finds it. The methodological eraser is waiting. It has a natural explanation ready. The explanation fits. The case closes. The second eraser does its work without anyone noticing that a question was not asked. Not one erasure. Two, one that destroys what is there. One that determines what we look for in what remains. The consequence of this second erasure is something the source of this question puts plainly and without comfort. Whether any past geological anomaly currently classified as natural might in fact be artificial is a question that is, with current methodology, unanswerable. Not difficult to answer. Unanswerable. The method that would need to answer it is the same method that, by its design, will not ask the question in the first place. We are standing in a dark room with a very good flashlight. The illuminated area is genuinely, reliably known. Everything the beam has touched has been examined carefully and honestly. But the room is large, and the shape of the room in the dark is not something the beam can determine by sweeping more carefully across the area it already reaches. This is not an argument against science. That would be like arguing against the flashlight, because it cannot light the whole room. The flashlight is the best tool we have. It is the best tool that has ever existed for knowing what it illuminates. The problem is not the tool. The problem is the assumption that the lit area is the whole room, and it may not be. So hold those two things together for a moment. The room is dark. The method that lights it cannot ask certain questions, and yet the silence of the rock is not the only silence we have been reading. There are two more channels of evidence that people reach for when this question gets asked. They are worth examining carefully, not because they close the question, because they narrow it, and the shape of what remains after they have done their work is worth understanding precisely. The first is the fossil fuel argument. It is probably the most persuasive popular case against any prior industrial civilization, and it goes like this. Coal, oil, and natural gas have been sitting underground for hundreds of millions of years. We found them. We extracted them. We burned them. If a civilization had existed before us and followed anything like our path, it would have done the same. The pantry would be empty when we arrived, but when we arrived, the pantry was full. Every coal seam we have ever opened was intact. Every oil field we discovered was waiting. The reserves were untouched. Think about what that implies. Imagine stepping into an abandoned house and finding the kitchen exactly as someone left it. Full cabinets, fresh bread on the counter, a refrigerator humming with food. You would not conclude that a family lived there for generations. The fullness of the pantry is itself the evidence that no one was home. This is a genuine argument. It carries real weight. And for civilizations that followed our specific trajectory, it may be decisive. But here's where it gets strange. Coal did not always exist. The vast deposits of coal that powered the Industrial Revolution formed during the Carboniferous era, roughly 300 to 360 million years ago. Before that period, the chemistry was wrong. The conditions were wrong. No coal had yet accumulated in any quantity worth the name. A civilization existing 400 million years ago would have stood on a planet with no coal deposits and no large petroleum reserves. They could not have emptied a pantry that had not yet been stocked. Their presence would leave no trace in the fossil fuel inventory. None. Not because they were careful, because the fuel was not there to use. That is the first limit. The argument applies only to civilizations that existed after the Carboniferous formed those deposits. Before that window, the pantry logic simply does not apply. The second limit cuts differently. It does not depend on timing. It depends on a hidden assumption buried in the argument's architecture. The pantry argument assumes that any sufficiently advanced civilization would use fossil fuels, that our path is the path, that the particular sequence of technologies humanity followed is the only sequence that leads to complexity. It is not. Geothermal energy is available beneath every continent on Earth. Iceland today runs almost entirely on geothermal and hydroelectric power. A civilization in a different geographic context, with a different starting set of resources, might have followed that route from its first century of development and never touched a coal seam. Solar energy has fallen on every square meter of land for billions of years. Plants have been capturing it since long before any animal existed. A civilization with different biochemistry or with a different relationship to the living world might have cultivated biological power sources entirely. Engineered organisms. Living machines we would not recognize as technology because they would look, to us, like nature. The pantry argument assumes we know what tools an advanced civilization would reach for. We are reasoning from a sample of one. So what do the untouched fuel reserves actually tell us? They tell us something real. They tell us that no civilization on our specific trajectory, burning the specific fuels we burn, came before us in the window after the Carboniferous formed those deposits. That is a genuine constraint. It rules something out. But it rules out one path, not all paths. The argument narrows the possibilities. It does not close them. Both limits together leave a door open. A civilization before 360 million years ago would not register in the fuel inventory at all. A civilization after that point, but one that never relied on fossil fuels, would also leave the pantry untouched. The full shelves are evidence. They are just not the universal evidence they first appear to be. Now consider a different kind of inventory, not the planet's storeroom, the species' memory. Where the fossil fuel argument is hard evidence preserved in rock, oral tradition is the softest channel we have. No chemistry, no isotope ratios, no sediment layers, just stories, passed from one person to the next, generation by generation, across time. Think of oral tradition as a rope bridge stretched across a canyon. A well-made bridge holds for a while. The ropes fray over years. After a few thousand years, what was a bridge is a suggestion. After more time than that, it is gone. And you cannot tell from the other side of the canyon that a bridge was ever there. What was history becomes legend. What was legend becomes myth. What was myth becomes a feeling without a name. The 4th century BCE philosopher Plato wrote about Atlantis. He described a powerful civilization that vanished 9,000 years before his time. That places the event, by his telling, roughly 11,000 years before now. Whether Plato was recording something real, repeating a distorted tradition, or constructing a philosophical allegory is impossible to determine from the text alone. What is certain is the arithmetic of transmission. From 11,000 years ago to Plato's time, approximately 400 generations of people would have carried that story, each one passing it to the next, each one changing it slightly, compressing it, adding to it, losing pieces. A game of telephone played across 4 centuries of generations. By the time Plato wrote it down, whatever cargo the original story carried had been through 400 hands. But there is something that cannot be dismissed quite so easily, and it sits underneath the Atlantis story and dozens of others. Flood myths appear across cultures that had no shared texts and no plausible recent common ancestor that would have transmitted the story directly. Mesopotamian tablets describe a great flood, a family on a boat, a world remade. Greek tradition records Deucalion and his wife surviving a deluge sent by the gods. Hindu scripture preserves the story of Manu warned by a fish to build a vessel before the waters came. Chinese legend describes Gun and Yu battling catastrophic floods that covered the land. Indigenous American traditions across separate nations, with no connection to each other or to Eurasia, remember waters rising over the world. Not one culture, not two. Cultures on opposite sides of the planet, with no shared history, all remembering a flood. That pattern is worth sitting with. Here is a possible substrate for it. 12,000 years ago, sea levels were more than 100 meters below where they are today. 100 meters. That is roughly the height of a 30-story building. Submerged since then. The coastlines our ancestors knew were gone. The settlements they built along shores and river mouths and tidal flats are underwater now. And the melting was not a sudden catastrophe. It was gradual. Thousands of years of slow, steady rise. A family living through that era would have experienced grandparents who remembered the shore 3 days' walk from the village, while their grandchildren walked only 1 day to reach it. The sea was coming closer. The world they had known was drowning. Generation by generation. Oral tradition does not preserve gradual processes well. It compresses them. A change that unfolded across 2,000 years becomes, in the retelling, a single event. A season of storms. A punishment from the gods. The ice melted slowly. The story says the waters came. That may not be coincidence. It may be the imprint of a real, global geological event encoded in the oldest stories human cultures carry. But there is a hard limit here, and it has to be named clearly. Oral tradition holds for roughly 2,000 to 3,000 years before degradation becomes severe. Beyond that threshold, the ropes of the bridge have frayed past the point where you can read what the original was. What survives past that boundary are echoes, fragments, shapes without names. Myths are not scientific evidence. They cannot be radiocarbon dated or peer-reviewed or measured against a control. They carry no chain of custody. The flood stories might reflect a real geological trauma. They might reflect a universal human tendency to project catastrophe backward onto a lost golden age. They might be both. The question is structurally difficult to resolve. What they represent is the outer boundary of human memory, the farthest reach of the rope bridge before it dissolves into the fog. Beyond that threshold, only stone and sediment remain. And we have already seen what stone and sediment do with evidence across deep time. The fossil fuel argument and the outer edge of oral tradition together draw a map with a specific shape. No civilization on our energy trajectory in the last 360 million years. No reliable human memory beyond a few thousand years. Both are real constraints. Both are meaningful. Both close certain doors. But the question did not live behind those doors. It lives in the deep time beyond them, in the intervals the rope bridge cannot reach, in the eras when the pantry had not yet been built. And what sits in that darkness is still waiting for a different kind of light. That different kind of light was already waiting. It had been waiting beneath a farmer's field in southeastern Turkey for over 10,000 years. In 1994, a farmer near the city of Şanlıurfa was working his land in the usual way. His plow struck something hard beneath the surface, not a buried stone of no consequence, not a forgotten foundation from some local medieval building. What he struck was a carved limestone surface far older than anything nearby, far older than any stone that had any right to be there. A German archaeologist named Klaus Schmidt came to look. He recognized almost immediately that this was not Roman, not Greek, not Persian. It predated all of them by a margin that made those comparisons almost meaningless. Schmidt would spend the rest of his life excavating what the plow had grazed. The site was called Göbekli Tepe. In Turkish, it means belly hill. A gentle, unremarkable name for one of the most disorienting places on the surface of the planet. What they found inside it required a complete recalibration of what we thought we knew about human history. The builders had raised massive T-shaped limestone pillars. Some of them stand 5 meters tall. Some of them weigh 50 tons. That is the weight of a fully loaded semi-truck. 10 elephants standing together, each pillar quarried from bedrock, carved by hand, transported, and then raised upright into precise stone circles. Not a single pillar, but dozens. Not a single circle, but multiple rings, nested and organized, built with deliberate geometric care. The age of the site is 11,600 years. Sit with that number for a moment. Stonehenge would not be built for another 6,000 years after Göbekli Tepe. The Egyptian pyramids were still 8,000 years in the future. Writing had not been invented. Agriculture had not been invented. The people who built this were hunter-gatherers. They followed animal herds across a landscape that had no cities, no permanent settlements, no kings, no priests with formal titles, no surplus grain stored in granaries, and yet they organized the labor of hundreds of people over years, possibly decades. They fed those hundreds of workers while those workers were not foraging or hunting, which means someone was providing food for a non-foraging workforce at scale. They had the engineering knowledge to move 50-ton stones across terrain. They had the geometric intelligence to lay out precise circles in limestone on a hill. Here's what the textbook said before Göbekli Tepe. Farming came first. Farming created surplus. Surplus allowed specialization. Specialization created priests and architects. Priests and architects built monuments. The sequence was as familiar as a nursery rhyme, taught in classrooms, repeated in documentaries, treated as settled. At Göbekli Tepe, the sequence ran exactly backward. Monuments came first. Agriculture came after in the same region, in the same centuries that followed. The monument did not wait for the farm. The farm may have followed the monument, not the other way around. The standard progression was not wrong at the edges. It was wrong at the foundation. The carvings on the pillars add to the strangeness. Foxes, snakes, scorpions, cranes, wild boars, animals rendered with a precision and artistry that implies long tradition, accumulated technique, a visual culture that had been developing for some time. And alongside the recognizable creatures, figures that appear to be partly human and partly something else. We do not know what they meant. We do not know what story they told. The language and belief system of the builders are gone entirely. Their name for themselves is gone. Whatever they called this place, whatever word they used for what happened here, nothing survives. There are no living quarters at Göbekli Tepe, no grain storage, no defensive walls, no evidence of permanent habitation. By every measure, this was a sanctuary, a gathering place, a structure built not to house bodies but to house something else entirely. And then, roughly 8,000 years ago, the builders did something that has no simple explanation. They buried it, not haphazardly, not abandoned and slowly covered by accumulating sediment over centuries. Deliberately, intentionally. The circles were filled in. The pillars were covered. The mound was smoothed. And the people walked away. Why they did this is unknown. What the burial signified is unknown. Whether it was ritual, precautionary, reverential, or something that has no name in any language we have ever spoken is entirely unknown. We have the evidence of the action. We do not have the reason. After the burial, the hill sat, quietly, invisibly. The Hittites came and built their empire and fell. The Assyrians followed. The Persians followed them. Alexander's armies passed through the region. The Romans built roads and towns and aqueducts across this same landscape. The Byzantines inherited the region. The Ottomans inherited it after them. Civilization after civilization walked over this ground, farmed it, grazed animals on it, built homes nearby. Not one of them found what was beneath. But here is where it gets strange. In 1963, an archaeological survey team actually visited the mound. They looked at it. They assessed it. They classified it as a medieval cemetery, not worth excavating, and left. They were not careless. They were trained. credentialed, methodical. They looked at the hill and saw what their framework prepared them to see. And they left the truth behind. The truth waited another 31 years, until Klaus Schmidt and a farmer's plough in 1994. Think about what that sequence implies. A site of extraordinary complexity and age was assessed by modern archaeologists with proper tools and training. It was dismissed. It waited 3 more decades before anyone looked again. And now, consider the longer span. Göbekli Tepe was buried beneath continuously inhabited ground, in a region with one of the densest and most thoroughly documented histories on Earth. Armies camped here. Scholars lived nearby. It was never hidden in a jungle or submerged under an ocean. It was under a farm. An ordinary hill with an ordinary name. And it stayed invisible for more than 10,000 years. This is not a hypothetical. Not a thought experiment. Not a speculative scenario offered as a possibility. It happened. It is documented. It is accepted by every archaeological institution on the planet. A massive complex of monumental architecture built by a sophisticated and organized people remained completely invisible for over 10,000 years in a region of continuous human habitation, survived a modern survey that dismissed it, and was finally recognized by one scientist who happened to look at it with different eyes. The standard objection to the idea that major human achievement could be hidden is that we would have found it by now. We would have found evidence. Something would have surfaced. The absence of evidence would not persist. Göbekli Tepe is the answer to that objection, not a theoretical answer, a physical one, an answer you can visit. And Göbekli Tepe is 11,600 years old. The question this investigation is asking reaches back hundreds of millions of years. The geological processes described in the earlier chapters of this investigation are not measured in thousands of years. They are measured in millions and tens of millions and hundreds of millions of years. If a hunter-gatherer cathedral could hide for 10,000 years in plain sight, under a farmer's field in one of the most continuously inhabited regions of the planet, what could hide across geological time, under the grinding weight of subduction and metamorphism and erosion across the full dark length of deep time? The question is no longer abstract. It has an address. It has a name. Belly Hill in southeastern Turkey, 15 kilometers from a city that still exists. And what was found there is only one layer of the answer. The deeper layers are still ahead. Those deeper layers begin right where the builders of Göbekli Tepe were standing. They begin in the world those hunters were rebuilding from. Because the site at Şanlıurfa is 11,600 years old, and 11,600 years ago, the world had just come through something. Not a quiet transition, not a gradual shift, a catastrophe. To understand what the Göbekli Tepe builders inherited, you have to understand what happened to the world just before they picked up their tools. 12,800 years ago, Earth was warming. The great ice sheets that had covered much of North America and Europe for tens of thousands of years were retreating. Glaciers were melting back from the valleys they had occupied. Forests were advancing northward, following the warmth. Animals were expanding into new ranges. To any human alive at that moment, the trajectory would have looked clear. The cold was losing. The world was opening up. Then it stopped. Something happened around 12,800 years ago. Temperatures in Greenland plummeted by 14 degrees Celsius, not over centuries, not gradually, in increments too small for a human life to register. Within a human lifetime, possibly within decades, a person who had grown up watching ice retreat watched it return. The world that had been opening closed again. Hard. Here's where it gets strange. The cause of this reversal is still debated among scientists today. The leading hypothesis involves the Atlantic Ocean's circulation system, the vast conveyor of warm tropical water that carries heat northward. At some point during the warming, enough cold meltwater flooded off the retreating ice sheets and into the North Atlantic to disrupt that conveyor. The warm current slowed. The heat it had been delivering to the northern latitudes stopped arriving. An alternative hypothesis points to a comet or asteroid impact on the ice sheet itself, triggering a cascade of cooling effects across the atmosphere. Scientists are still arguing. What is not in dispute is what the record shows. The warmth ended, abruptly, and the cold that followed was not brief. The period has a name. It is called the Younger Dryas, after Dryas octopetala, a small 8-petaled Arctic flower adapted to cold, rocky, treeless ground. The reason this flower gives the period its name is telling. When scientists extracted sediment cores from lake beds and bogs across Europe, they found the pollen of Dryas octopetala suddenly appearing in layers where it had no business growing. The flower had advanced southward into terrain it should never have occupied. Its pollen in the sediment is a marker, the record of a cold world spreading where warmth had been, a botanical tombstone for a climate that died. The Younger Dryas lasted roughly 200 years, more than 40 human generations. Think about what that means in terms of living memory. The generation that watched the warmth end could tell their children what the world had been like before. Those children could tell their grandchildren, but within 3 or 4 generations, the warm world would have passed beyond the reach of anyone alive. The world of cold and scarcity would have been the only world anyone had ever known. To people born into the Younger Dryas, the warmth before it would not have been history. It would have sounded like myth. This is how cultural memory breaks. Not through deliberate erasure, not through the burning of books or the suppression of traditions, through unbearable pressure. When survival is hard enough, the energy required to maintain traditions, to rehearse the stories, to hold onto the knowledge of a world that no longer exists, is energy that cannot be spent. It gets redirected towards staying alive, and the knowledge does not get destroyed. It simply does not get passed on. One winter too severe, one community too scattered, one generation that did not have time to listen, and the chain breaks. In North America, the record of what broke during the Younger Dryas is written in the absence of animals. Before 12,800 years ago, North America held a megafauna, a community of enormous creatures that had no equivalent anywhere on Earth. Mammoths, mastodons, saber-toothed cats with fangs the length of a human hand, giant ground sloths that stood taller than modern elephants, all of them present in the geological and fossil record right up to the Younger Dryas boundary, and then gone. The disappearance of so many large species in so short a geological interval is one of the most dramatic biological events of the last 100,000 years. And the animals were not alone in disappearing. The Clovis culture vanished at the same boundary. The Clovis people are known to archaeologists by a very specific artifact: a fluted spear point, a stone blade with a distinctive channel carved along its base, found across thousands of archaeological sites throughout North America. These points are distributed across an enormous geographic range, evidence of a widely spread and apparently successful hunting culture. They appear in the record, they flourish, and then, at the Younger Dryas boundary, they are simply gone. Whether the Clovis people died, scattered into groups that became unrecognizable in the archaeological record, or transformed so thoroughly that their descendants left no traceable continuation, is not known. The question has no answer. The record ends. Now comes the part that requires honesty about what we know and what we are speculating. We know the cultural disruption happened. The archaeological record documents it. The Clovis disappearance is not a hypothesis. The megafauna extinction is not a hypothesis. The 14-degree temperature drop in Greenland is not a hypothesis. These are measurements, preserved in ice cores and sediment records, and the simple presence or absence of species across a geological boundary. What we do not know is what else was lost, and this is where the ground becomes less solid, and it is worth saying so plainly. If a relatively advanced society existed during the warm period before the Younger Dryas, the catastrophe that followed could have killed most of the population. The survivors would have been too desperate to preserve traditions that did not bear directly on staying alive. The chain of oral transmission, already fragile across generations in good conditions, would have snapped under that kind of pressure. Within a few generations, libraries of oral knowledge could have been extinguished. Songs encoding astronomical observations, stories carrying agricultural techniques or navigational methods, memories of places that existed during the warm world and were later drowned by rising seas, ways of understanding the world that no one now living has any trace of. We cannot prove this happened. We do not know whether any such society existed. The evidence that would tell us is exactly the kind of evidence that 1,200 years of cold, scarcity, and population collapse would have erased most thoroughly. But we know the mechanism is real. We know the younger Dryas was long enough and severe enough to accomplish exactly this kind of erasure. More than 40 generations is not a gap that oral tradition crosses intact. The rope bridge, stretched that far, over conditions that brutal, does not hold. The flood myths and Golden Age stories that appear across so many unconnected cultures may be fragmentary memory of this lost, warm world. They may carry the shape of a disruption so large it left an echo even in stories that had been degraded past the point of information recovery. We cannot prove this. We cannot extract historical data from a legend. But the timing fits in a way that is at minimum worth acknowledging. The Younger Dryas ended approximately 11,600 years ago. The world warmed again. The survivors came out from wherever they had retreated. They began to rebuild. They built places like Göbekli Tepe. They invented agriculture, possibly at Göbekli Tepe itself. They began the long reconstruction of human civilization from whatever fragments remained after 100-200 years of winter. But they did not remember what came before. We treat human prehistory as a gradual upward line. Knowledge accumulates. Skills build on skills. Generation by generation, the inventory of human capability grows. The reveal is that this picture is wrong in a specific and important way. A 1-2-3 year cold snap erased entire cultures within a historical scale time, not across geological eons, not across the kind of spans measured in millions of years. Within a stretch of time that is, by the standards of this investigation, almost negligibly short. And if that kind of erasure is possible within 1,000 years, inside the narrow window of the last 20,000 years of human history, then the question of what might have been erased across geological time becomes something else entirely. Something with a different weight. The Younger Dryas is not the end of what the record holds. It is closer to the beginning of what has been lost. And the record goes back much further than 12,800 years. Some of that record goes back further than any myth can reach. But before we go there, some of the myths need to be set down. Not reluctantly. Cleanly. Some lost civilization stories cannot survive contact with how the world actually works. Not because the questions behind them are foolish, because the specific claims are wrong, and getting them wrong costs us something. It muddies the water at exactly the point where clarity matters most. So let's bury the wrong versions carefully, with the respect owed to any idea that was once worth taking seriously, and move on. Lemuria came first. In the 1860s, scientists noticed something genuinely puzzling. Lemur fossils were turning up in Madagascar and in India, but nowhere in between. The Indian Ocean sat between those two places with no visible bridge. The working hypothesis was reasonable for its time. Perhaps a continent had once connected them. Perhaps it had sunk. It was the kind of inference any careful scientist might draw from the evidence available. They called it Lemuria. But here's where it gets strange. The same fossil distribution that seemed to demand a sunken bridge was actually pointing at something else entirely. Something more remarkable. Plate tectonics, fully understood only in the 20th century, showed that India and Madagascar had once been part of the same landmass. They did not need a bridge. They had been neighbors. India broke away, drifted north over tens of millions of years, and eventually collided with Asia with enough force to raise the Himalayas from the seafloor. The lemur fossils were not evidence of a sunken continent. They were evidence of continental drift. The same data. A completely different answer. A better one. Lemuria was not wrong in a careless way. It was wrong in the way bloodletting or the four humours were wrong. It fit the evidence available at the time. Then the evidence grew, and the answer changed. Mu did not have that excuse. In the 1860s and 1870s, a man named Augustus Le Plongeon travelled to the Yucatan to study Mayan ruins. He returned with an extraordinary claim. He had decoded the ancient Mayan texts, he said, and they described a great Pacific continent called Mu, a civilization 12,000 years old, advanced, vast, sunk beneath the ocean in a catastrophe of biblical proportions. The problem was direct. Le Plongeon could not actually read Mayan. His translations were not approximations. They were not educated guesses. They were fantasy dressed in the vocabulary of scholarship. Later writers picked up the story, added details, elaborated the maps, named the kings, but the foundation was never real. Mu did not begin as a distortion of genuine evidence. It began as a misreading, and it built upward from there. There is nothing at the bottom to recover. And then there is geology, which closes both cases permanently. Continental crust and oceanic crust are not the same material. Continental crust is lighter. It floats higher on the mantle beneath it, the way a block of wood floats on water. You can crack it. You can push it sideways. You can fold it into mountain ranges or stretch it until it thins. What you cannot do is make it sink. The physics will not allow it. When the mantle beneath a continent shifts, the continent rides along. It does not submerge. Oceanic crust does subduct. It does descend into the mantle and melt, but at rates measured in tens of millions to hundreds of millions of years per cycle. The Atlantic Ocean widens by roughly a fingernail's width per year. These are not human timescales. These are not even ancient civilization timescales. These are mountain range timescales, the same timescales that take hundreds of millions of years to recycle a seafloor. Continents do not sink in 10,000 years. They do not sink in 100,000 years. Plate tectonics did not cast doubt on Lemuria and Mu. It made them physically impossible, not unlikely. Impossible. Geology did not raise questions about these stories. Geology killed them, but the water did rise. Around 5600 BCE, something real happened. The Mediterranean Sea pushed northward and broke through a land barrier at what is now the Bosphorus. On the other side sat a freshwater lake. The salt water poured through. Some researchers believe this was catastrophic, a roaring waterfall of salt water flooding an inhabited basin over months or years, transforming a lake into what we now call the Black Sea. Others argue the flooding was more gradual, a slow transgression over centuries. Whether it happened fast or slow is still debated. What is not debated is that it happened. Real people lived on those shores. Real farms bordered that freshwater lake. Real villages sat at elevations that became the seafloor. And this was not an isolated event. Coastlines all around the world were moving as the glaciers of the last ice age continued to melt. Sea levels that had been more than 100 meters lower than today were rising across centuries, across millennia, drowning low-lying land that communities had occupied for generations. Shores that grandparents had known became unreachable. Fishing grounds vanished beneath the waves. Entire stretches of inhabited coast went under, not in a single dramatic moment, but steadily, relentlessly, over lifetimes. Stories grew in the telling. A village became a city. A city became a civilization. A civilization became a wonder outshining everything the survivors had built on higher ground. The kernel was true. The water rose. The shore moved. What seemed permanent was not. So flood myths may not trace to a single global event. The specific claims of Lemuria and Mu and a sunken Atlantis describe literally a wrong. but the emotional memory underneath them, the knowledge that the world was once arranged differently, that the sea once took something permanent and made it gone. That is not invention. That is a true thing, worn smooth by too many retellings. The specific myths are dead. The questions behind them are not. What have we forgotten? What lies beneath us? What would we find if we could see through time? These are not the questions of wishful thinking. They are exactly the questions science was built to answer. And clearing the false versions out of the way is not a retreat from the mystery. It is the first step toward asking it rigorously. The real version of the question, the one that survives geology, survives plate tectonics, survives everything the ledger of evidence demands, is still waiting. Here is the real version of that question. Not myth dressed in scholarly vocabulary. Not a lost continent waiting to be rediscovered beneath the waves. A peer-reviewed paper written by credentialed scientists, published in a journal indexed by NASA. The kind of question that survives every demand for evidence, because it does not make a claim. It holds up a mirror. But before the mirror, there was a number. In 1972, a technician at a French nuclear facility was processing uranium samples from a mine in Gabon, West Africa. The uranium had been extracted from a place called Oklo. Routine work. The technician ran the isotope ratios and found something that should not have been there. The ratio was off, not by much, a fraction of a percent. But in nuclear chemistry, a fraction of a percent is not a rounding error. It is a signal demanding explanation. Here is what scientists believed at the time. Uranium isotope ratios are a constant. They vary slightly across different geological sources, but they fall within a known range. A deviation outside that range means something consumed some of the uranium first. Something depleted it. The question was, what? The answer rewrote what physicists thought nature was capable of. Roughly 2 billion years ago, deep in the rocks at Oklo, groundwater seeped through cracks into an unusually concentrated deposit of uranium ore. The water did something specific. It slowed the neutrons released by natural radioactive decay. Slowed neutrons split uranium atoms more efficiently. Splitting atoms released more neutrons and more heat. The heat drove the water away. Without water, the neutrons moved too fast to sustain the reaction. The reaction paused. The rock cooled. The groundwater crept back in. The cycle started again. This continued for hundreds of thousands of years. A natural nuclear reactor, running itself, stopping itself, restarting itself, with no engineers, no containment vessels, no minds of any kind. Just physics and geology and time. These natural reactors produced fission products, isotope ratios, decay chains, the same signatures we find in the spent fuel rods of modern nuclear power plants. For decades before Oklo was discovered, fission products in ancient rock had been considered a clean techno-signature, something only intelligent beings could produce. The reasoning seemed airtight. Sustained nuclear fission requires precise engineering, controlled geometry, deliberate moderator design. No natural system could accidentally satisfy those conditions. Wait. Oklo satisfied every single one of them. 2 billion years before the first controlled fission reaction in 1942. With no intelligence involved whatsoever. Sit with what this means. A signature that seems to require technology might instead require water, uranium, and patient mathematics. The rock does not distinguish. It records the reaction. It does not record the cause. This cuts in two directions, and both cuts are uncomfortable. The first, natural explanations deserve methodological priority because nature has demonstrated it can produce signatures we associate with intelligence. The second, distinguishing artificial from natural becomes extraordinarily difficult, and in some cases, it may be impossible. Oklo was recognized as natural because we understand the physics well enough to model it. We can reconstruct, step by step, exactly how the groundwater geometry and the ore concentration and the neutron moderation aligned to produce sustained fission. The natural explanation fits so well It closes the question completely. But what about anomalies that sit at the edge of our knowledge? What about signatures in ancient rock that we do not yet have a complete model for? We correctly follow the evidence toward natural explanations. We close the cases. And somewhere in the closed cases, there might be something we did not know to look for. That is the haunting question Oklo leaves behind. Two scientists decided to take that question seriously, not speculatively, rigorously. Gavin Schmidt is a climatologist at NASA. Adam Frank is an astrophysicist at the University of Rochester, both established researchers. In 2018, they published a paper in the International Journal of Astrobiology, a peer-reviewed publication laying out what they called the Silurian hypothesis. They borrowed the name from the Silurians, fictional intelligent reptiles in the television series Doctor Who supposedly evolved on Earth before mammals. The joking name signals the speculative framing. The paper itself is not joking. The question Schmidt and Frank asked was precise, not, did an industrial civilization exist tens of millions of years ago? That would be a claim requiring evidence. Their question was different. If one had existed, how would we know? The hypothesis is not a claim. It is a mirror. They walked through the possible signatures, carbon isotope shifts, synthetic molecules, unusual element concentrations, extinction pulses, climate anomalies, the same signals we laid out in this investigation as evidence of our own industrial era. For each one, they asked how much would survive over geological time, and whether what survived would be distinguishable from natural processes. The answer in every category was the same. Not that the evidence would fail to exist. It would exist, but it would be transformed beyond recognition. A carbon isotope spike compressed to micrometers. Polymer molecules degraded past identification. Element anomalies indistinguishable from volcanic pulses or marine anoxic events. After tens of millions of years, the signal does not vanish. It drowns. Here is where it gets strange, and where the implications reach further than Earth. We have now found thousands of exoplanets. The next frontier in planetary science is searching for biosignatures and technosignatures on those distant worlds. Chemical fingerprints of biology or industry, detectable across light years in the spectrum of starlight, filtered through a foreign atmosphere. This is active, funded, serious scientific work. But the Silurian hypothesis asked a question that should stop that work in its tracks, at least long enough to reckon with it, honestly. If we cannot reliably detect technosignatures on our own planet, in our own rock, with direct physical access, in a case where we know exactly what signatures to look for, what can we actually expect to detect across light years? What are we calibrating our instruments against? The paper was never primarily about Earth. It was about calibrating expectations. It was about recognizing that our tools are limited by the questions we remember to ask, and that a search method shaped by one kind of civilization, looking for evidence of itself, carries blind spots we have not yet mapped. Schmidt and Frank did not argue that ancient civilizations existed. They demonstrated something more unsettling, that we have no reliable method to prove they did not. The absence of evidence is not evidence of absence when the evidence has had millions of years to become indistinguishable from geology. The empty room with the sealed door. Silence inside could mean no one was ever there. It could mean everything was ground to dust so thoroughly that the room now looks empty even though someone once stood in it. The door is sealed. We cannot see inside. We can only reason about what the silence means, and reason has limits here. Radioactive isotopes decay at known rates. They are, in one sense, ticking clocks we can hear but not see. We can measure the decay. We can calculate backward to the original event. But the clock only tells us when. Not who, not why, not whether anything intelligent was involved or whether it was water and uranium and physics again, finding their way to the same chemistry by a different route. The paper does not ask for belief. It asks for honesty. Refine the ignorance before refining the answers. Sit with the discomfort of a question that cannot yet be closed. And that discomfort is not a stopping point. It is a method. The same method science has always used when a trusted assumption turns out to be softer than it looked. What other signatures have we filed under natural causes because no one thought to ask whether the file should stay open? That question is still live. And the tools that might answer it do not yet exist. So turn the question around. We have spent this entire journey looking backward, looking for ghosts, looking for what might have come before us, what might have left a mark, what might have been erased so thoroughly that only chemistry remained. We have asked whether someone else might have stood where we are standing, whether their cities dissolved into the mantle, whether their legacy compressed into a thin, dark line that we have already walked past without recognizing it. But here is where it gets strange. We are leaving that line right now, not in the distant future, not gradually, over centuries to come. Right now, in the sediment forming today, in the ocean floors accumulating layer by layer, in the ice cores thickening each winter at the poles. The investigation we have been running on the past is also a description of the present. The chemical signature we have been asking whether we could detect in ancient rock is the same signature we are currently writing into new rock. We have been reading the field notes of our own crime scene. The numbers are not soft. The current extinction rate is somewhere between 100 and 1,000 times higher than the natural background rate. The natural rate before us was slow enough that loss and recovery stayed roughly in balance over geological time. That balance is gone. 40,000 species are currently threatened with extinction. Not over the next million years. Now. In the time it takes to read this sentence, something is being pressed a little further toward the edge. This is the 6th mass extinction in Earth's history. The first 5 were caused by forces the Earth had encountered before. Volcanic eruptions releasing carbon over millions of years. An asteroid moving at tens of kilometers per second. Ocean chemistry shifting as seafloors spread. Enormous impersonal forces with no direction and no intent. This one is caused by a single species. That has never happened before. Not once in 4.5 billion years. And long after our cities are gone, long after our books and hard drives and photographs and recordings have decayed into inert chemistry, the rock will remember. Not our stories, not our names, not what we loved or feared or built or dreamed. The rock will remember a thin boundary layer, perhaps a centimeter thick, perhaps less. A dark line where the sediments change. Elevated carbon isotopes from fossil fuel burning. The same signature we looked for in ancient layers and found ambiguous. Tiny fragments of broken down plastic. Molecules that should not exist in any natural rock. The same technofossils we identified as our most unambiguous marker. A distinctive radioactive fallout spike from weapons testing. The same plutonium signature that began in 1945 and will persist for hundreds of thousands of years. And beneath the line, a sudden drop. Fewer shells, fewer bones, fewer spores. The extinction signature written globally into every sediment forming at this moment. All of human civilization compressed into what the source calls a geological whisper. A whisper that screams if you know how to read it. Think about the legacy we imagine for ourselves. Art, science, music, monuments, the things we build to outlast us, the things we name for each other. We spend enormous effort imagining what future minds will know of us, what will survive, how we will be understood. It is one of the things that makes us distinctly human, the desire to be remembered. But here is the reveal. The only legacy guaranteed to survive geological time is not art, not science, not music, not a single monument. The only legacy guaranteed to outlast erosion and subduction and metamorphism is the chemical evidence of our destruction. The carbon spike, the mass extinction, the synthetic materials, the tombstone written in plastic and plutonium. Not the things we hope to be remembered for, the things we could not help but leave. Imagine a geologist, 50 million years from now, holding a core sample, sliding a finger along the layers, reaching a strange band, carbon-enriched sediment, synthetic particles that should not exist in nature, chemical residue of something that burned hot and fast. They might run tests. They might debate. They might find no satisfying answer. Just evidence that something changed violently and briefly. An anomaly. A boundary. A dark line that does not match anything on either side of it. They will not know what we loved. They will not know that we looked up at the night sky and wondered. They will not know what music sounded like, what a city smelled like at dawn, what it felt like to be a human being standing on this planet in this particular sliver of time. That will all be gone. The instruments are not fine enough. The signal does not survive, but they will know we existed. They will know something was here, and that something burned through the world and then was gone. We have two choices about how to hold that. The first is terror. Everything we love will be erased. Every trace of what mattered to us will be ground into chemistry and compressed into a layer thinner than a fingernail. The universe does not keep records of what it contains. It just keeps moving. The second is something closer to comfort. We are part of the story, a brief chapter in a 4.5 billion year life. The planet will continue after us. Plates will move, new mountains will rise, new oceans will fill basins that do not yet exist. Something will evolve in the silence we leave behind, inheriting a world reshaped by our passage through it, the way we inherited a world reshaped by every extinction and upheaval that came before us. Some future mind may look at our dark line and wonder about us the way we have spent this journey wondering about what might have come before, humbled by the gap, reaching across it with instruments and questions, and the honest admission that the gap does not close. Both of those responses are true at the same time. Now return to the beach. The dark water is still there. The sand is still in your hand. 4.5 billion years stretching behind you into a darkness you cannot see the end of. 400 million years of complex life on this planet. 150 million years of dinosaurs. 300 years of industry. Those numbers have carried weight through this entire journey. Let them carry it now. Earth is not a museum. It is an eraser. That was not a threat when we said it near the beginning. It was not a warning. It was always just the truth. The structure of the planet. The way geological time works. Evidence does not accumulate here. It cycles. It transforms. It becomes something else. Absence of evidence is not evidence of absence. We looked for what would survive. We found almost nothing. Only chemistry. Only the faint signature of burning and dying. Not the things themselves, but the residue of the things. And even that residue becomes indistinguishable from geology over time, drowning in noise, compressed into micrometers, readable only if you know exactly what you're looking for. The silence in the stone is not an answer. It is a question that will never be fully resolved. A door we cannot open. A room we cannot see into. We do not know whether anything came before us. We do not know whether anyone will exist 50 million years from now to read our boundary layer and wonder. We do not know whether we are first. The paper does not resolve it. The geology does not resolve it. We are and will remain uncertain. What changed at the end of this journey is not the uncertainty. The uncertainty was always there. What changed is how we hold it. We are no longer afraid of the silence. We accept it. We are here now. We are asking these questions now. We are the part of the universe that became aware enough to look backward through geological time and ask who else might have stood in this position. That is not nothing. That is, if anything, the most remarkable thing we know of in the universe so far. Matter that became curious about the story it is part of. A planet that eventually produced something capable of reading its own history, even if the reading is incomplete, even if the oldest chapters are unreadable, even if some pages were burned before any eyes existed to see them. We may never know if we are first. We will certainly not be last. The planet has 4 or 5 billion years remaining before the sun changes enough to make the surface uninhabitable. That is more than enough time for something else to rise and fall and leave its own dark line. Maybe several somethings, maybe dozens, each one a chapter, each one a brief flash of complexity in a very long story. Our chapter is both infinitely meaningful and infinitely small. The questions matter even when the answers do not come. The investigation matters even when the file cannot be closed. The beach stretches behind you into darkness. The sand is still in your hand. You cannot see where the shoreline ends. You cannot count the grains. 4.5 billion years of them, each one a year, in which something happened and left a trace or did not, in which something lived and died, and either entered the record or vanished without a mark. You are holding the last handful, the one that contains everything you know. The wave is coming. Close your eyes.